Hi guys. I had a lot of people asking me about homework from this past week, 12.3 and 13.1. So I decided to make another short tutorial video going over the whole thing. If you didn't finish it on time because you're stuck, then you can just request an extension and I can grant it to you. And here's me going over all the solutions. One by one, starting from 12.3. Question one says, if a state issued a license plate using the scheme of 3 letters followed by 3 digits, how many plates could it issue? And we did this exact question in class actually. 26 options for each letter. We're using the FCP for this one, right? So 26 to the third, 3 digits, so that'd be 10 to the third. The 3 is because there's 3 of them, 10 because there's 10 digits possible, 0 through 9, 26 because there's 26 letters possible. So that would be 1757600. Okay, number 2, how many ways can a group of 19 people elect president, vice president, secretary? This is an NPR question because we have position. From the 19, you're going to select 3 offices, president, vice president, secretary. So that would be 5, 8, 1, 4. Number 3, how many 3-member committees can be formed from a group of 6? Doesn't specify any, what is it? Like order, no order or position within the committee. So it's just NCR combination this time. 6 choose 3, which is 20. Let's make this a little bigger on the side. Okay, number 4, state's license plate consists of 3 letters followed by 4 numerals and 247 letter arrangements not allowed. We basically did this question as well in class. The way to do it is there's 26 times 26 times 26. That's how many letter combination, there are 3 letters, but except you got to subtract the 247 that are not allowed. Close that off in parentheses. And then multiply that by how many number combinations there are, and there's going to be 10 to the 4th because there's 4 numerals this time. So how many altogether? We got 1732900. Okay, number 5, boats often relay messages by using flags. How many messages can be made using 5 flags out of a package of 39? All right, so in this situation, there's actually an argument to be made that it's a combination, but we're assuming that the order of the flags appearing makes a difference. So yeah, because you could consider those to be different messages, right? So we're going to use a permutation for that reason. 39, always a bigger number first, 39 first, and then 5. So we're going to get 69, 090, 840. Okay, number 6, you flip a coin 8 times and you keep a record of results. How many ways can you obtain at least one tail? Again, a similar question we did in class, right? First thing you do is look at how many ways can you flip a coin 8 times. That's 2 to the 8th. And then how many of those ways do you obtain at least one tail? Well, you pretty much always obtain at least one tail, except when you have 0 tails. So in other words, all heads, right? So you just subtract that one instance and you get your result there, 255. Number 7, a certain lock has 4 tumblers. Each tumbler can assume 7 positions. This is similar to like those suitcase locks, right? And so how many different possibilities are there? 7 positions for each tumbler, and there's 4 of them. So it'll be 7 times 7 times 7, or just 7 to the 4th. 7 times 7 times 7 times 7 times 7. That's it, right? Or anyway, 7 to the 4th. Yeah, 7 4 times. 2401 is the answer. Number 8, suppose a restaurant offers following prefix menu. And again, problem we saw in class, right? We go 1, 2, 3, 4, 5 options for the first. This is an FCP question. 3 options for the desserts and 4 options for beverage. So altogether 60, assuming that you order a meal consisting of 1 choice from each category. So it's kind of like if you go driving through a fast food restaurant, it's kind of the same, right? Like you pick which meal, like which burger you're gonna get, and then you pick which like side it comes with, and then you pick which beverage you want. You go like Popeyes, something like that. You pick like 2 sides, you pick a main course. Anyways, number 9, classify the problem as permutation, combination, either. In how many ways can 4 hearts be drawn from a deck of cards? Order is not important. Order not important. You can't pick the same card more than once. That's a combination. And so that'll be NCR. And then you're only choosing hearts. So don't choose from the 52 cards, only from the hearts, because you only want to select hearts, right? So 13, choose 4, and you get 715. There we go. Number 10, classify permutation, combination, either. Night watchman visits 130 offices every night to prevent others from knowing when he will be at a particular office. He varies the order. Varies the order. That sounds like a permutation to me. Visits these 130 offices. He's not going to visit the same one twice. So that would be a permutation. How many ways can you do it? And that would be 130 factorial ways, yeah? Or equivalently, NPR 130, 130. Okay. It's telling me that's undefined, which is not true. I think it's just it can't handle that large of a number. Unless you put it in this format for some reason. Whatever it is, it's 130 factorial because that's the number of ways you can permute 130 things, which is a gargantuan number. 10 to the 219th power. That means 219 zeros. Super huge. Anyway, next question. Classify the problem as permutation, combination, or neither. There are 4 boys, 4 girls at a party. How many ways can they be seated if they can sit down 5 at a time? And this is similar to a question again we saw in our class. In this case, we care where they sit, right? And there's 4 plus 4 is 8 total people. It's going to be NPR from the 8, selecting 5 of them to sit in some arrangement. So it's permutation, and the answer is 6720. Okay, number 12. Classify the problem as a permutation, combination, either. A shipment of 90 TV sets is received. 6 are chosen random to be tested for defects. And how many ways can 6 be chosen? Okay, so you're just choosing 6 from the 90. Doesn't matter which order you choose them in. So that's a combination question. And it's going to be NCR. Bigger number always first, 90. You're choosing 6 of them. And wow, that was bigger than I was expecting. 622, 614, 630. I guess that makes sense. So 90 is a pretty large number. And 6 is also not, it's not 1 or 2. So you get a pretty, you get a pretty good amount of those things to be multiplied together. 622, 614, 630. Okay, last one. The typical social security number is 555-475593. How many social security numbers are possible? The first 2 digits cannot be 0. Okay, so they give this typical social security number, and that's just to tell you that there are so many digits, right? So count the digits. You got 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So normally you'd say that would be 10 to the 9th power, right? Or in other words, 10 times 10 times 10. 3, 4, 5, 6, 7, 8, 9, 10. That's 10 copies of 10. Oh, I'm sorry, 9 copies of 10, I mean. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I did 1 too many. Okay, yeah, so 9 zeros, right? The thing is, though, the first 2 cannot be 0. That means you have 1 less option for the first 2 digits. So just change those to 9s. And there's your answer. Other option is just to say that means there's 9 to the 2nd times 10 to the 7. There's 7 digits that could be anything from 0 to 9, and 2 of them that could be, what is it, 1 through 9. Okay, so either way you do it, same thing. Answer is 810 million. And there you go. Let's check, make sure we didn't make any mistakes. And if we did, we'll just correct them. Let's see. Green check, green check, green check, green check, green check. Okay, looks good. Awesome. All right, guys. I'll see you in the next video. We'll talk about the 13.1 homework.